loved math. I had lots of mathematicians in my family. I'm Pedro Vieira. I'm originally from Portugal, and I did not really want to do exactly the same that my grandma, my mother, my father, my uncle, that everyone was doing. I want to do something a little bit different. I work here at Perimeter Institute in quantum fields and strings since 2009. I read some amazing popularization books, one by Einstein on relativity, the usual ones, Feynman and so on, that I had at home. And I had a very, very good physics high school teacher. And that's usually what makes it, I think. I think typically, if the high school physics teacher is very good and the student loves math, I think it's almost a deadly combination. It's irresistible. At PI, we like to say that there are no groups, that more or less all groups talk to all groups. But the common language for those conversations is quantum field theory. Because within physics, quantum fields is really the language that allows you to study physics at low energy, at high energy, at all possible energies. The quantum field part in particular is really very universal and very broad. And so one of the things we have to develop is this language, these techniques, for understanding problems that we already know how to solve, and perhaps more excitingly, to develop what are the new tools that we need to come up with to solve problems that we don't know yet how to solve. So that's one of the things I like to do a lot, is to think, here is a beautiful problem, it's well posed, we know we want to solve it, it's like there is a reward, please solve this problem if you can, and we don't know how to. And looking for those tools, looking for those ideas is what I love spending my day trying to do. So this is a very complicated object. It's a functional that depends on fields in the beginning, fields at the end. Sometimes we want to simplify things as much as possible to try to understand how things work. Our universe is too complicated. There are too many particles, there are too many parameters. So I'm asking, how do the simplest possible string theories work? Let's try to understand what are the rules of the game. What is the fundamental building block in string theory? What is the fundamental Lego out of which I build my string theory? I love its universality. I love the fact that I'm trying to develop tools, say, for studying what happens when quantum effects are very strong. When you crack a hard problem, you are solving not one problem, but 10, 100 problems at once is fascinating. It's really a gift that the universe gave us, that power of the theory.